The technology we're bringing to market would be able to boost energy density by about 20%, and then over the next couple of years we'll push it to about 40% improvement. The existing chemistry improves maybe 2% every couple of years, so we're really bringing a new battery chemistry to market for the first time in about 30 years. As I spent more time looking at batteries, it really turns out to be one of the hardest problems in the world.
Since its introduction in the 1990s, the rechargeable lithium battery has been the standard for everyday tech devices and electric vehicle power. As the world races toward an electric future, it needs something better to keep pace. Battery startups trying to build better batteries, ones with lower costs and better performance, believe big improvements are coming.
The lithium-ion chemistry has really reached its theoretical limits. Sila is a materials company that was founded with the mission of moving us to a new generation of battery chemistry, and that new generation of battery chemistry will enable further advances in energy density that'll allow electric vehicles to go further, be cheaper, as well as make for better consumer devices.
Sila is one of several startups that received major funding to continue working on their technology. Now, after about 10 years of research, they'll soon be ready for the commercial spotlight.
Things like wearable fitness trackers, smartwatches, wireless earbuds, cell phones, but it really is going to take us quite a lot of scaling up before we're in electric vehicles. And the hope is really to start in electric vehicles where we can deliver the highest performance, and then as we're able to produce the material at a larger and larger scale, bring down its cost and further bring down the cost of the battery, we would want to be in every passenger electric vehicle produced.
To do that, Sila has replaced the graphite in today's batteries with silicone to create silicone anode batteries. They say this change can deliver a better performance from a cheaper product.
The current lithium-ion battery uses what is called an intercalation chemistry. It has a graphite anode material and a metal oxide cathode material. And those materials are then assembled and wound into a cell that would either go into your electric vehicle or your cell phone. What we do differently is we replace the graphite anode that's in the battery today with a proprietary material that we've synthesized, and that material is able to store energy more densely than graphite, and so it allows us to pack more energy into the same cell. The simplest way to think about that is if we can store twice as much energy, let's say, in the battery that you use in your electric vehicle, then you need half as many batteries to go the same distance. And if you need half as many batteries, it'll cost you about half as much.
This could mean longer lasting gadgets, cheaper electric vehicles, and ultimately, a cleaner power grid.
What grid operators and utilities are going to want is predictable solar and predictable wind. And the way you get to predictable solar and predictable wind is to have energy storage coupled with it so that whenever the wind is blowing, you're charging the battery, and whenever the utility needs the power, you're discharging it. So we think that this chemistry is a huge accelerator for being able to deploy renewables from a few percentage points on the grid to replacing most fossil fuels around the world.
The long development timeline for these startups is a sign of how difficult pushing battery technology can be.
We're in our 8th year of operation as a business. We've raised about $125 million to date just to get to a place where we've solved the chemistry problem. It's that hard. It's taken almost a decade just to make the technology work. And so now the challenge shifts for us to really scaling it up. And it requires everybody to work together to get to the right answer. We have a deep belief that new battery chemistries become the standard after some years. We've seen that before. And so as we start to launch this chemistry, so long as we can get our production volumes up, then we expect that this chemistry or these kinds of chemistries will become the de facto standard for the next generation or so.
Hey, NBC News viewers, thanks for checking out our YouTube channel. Subscribe by clicking on that button down here and click on any of the videos over here to watch the latest interviews, show highlights, and digital exclusives. Thanks for watching.